So the reason that we talked about binary so much is that computers inherently operate in binary, but the real physical world is inherently analog. And since binary is digital and the real world is analog, if we want to get real-world sensor data into our software, we need to do an analog to digital conversion. So A to D, standing for analog to digital. So, for example, let's take a sensor. We have a magnetoresistive sensor as well as a force-sensitive resistor that we use as sensor. Those are our two sensors that are part of your HAP kit. Those voltages coming from those sensors will be changing continuously. And so if your hapkit board, which is a digital system, wants to understand them, there's special circuitry on your board which does this analog to digital conversion. So let's go through the process for that conversion that you need to understand so you know how to interpret the information that functions read on your hapkit board. So the first step is that the sensor generates an analog voltage on some pin. So it could be pin 13 like we played with before, or it could be some other pin. In fact, it should be not pin 13 because that's one of the digital pins, but it should be one of the specialized analog pins on your hapkit board or your Arduino board. So depending on what kind of board you have, you may not be limited to between 0 and 5 volts, but the setup that we have for your hapkit board, the analog voltages that are coming in should be between 0 and 5 volts. And try not to put anything beyond that, either negative or past 5 volts, because it could damage the board. It's not designed to handle other types of voltages. And don't worry, we've already set up the circuitry for your MR sensor and your force-sensitive resistor so that it will be between 0 and 5 volts. So the next step, this all happens in circuitry, so this is not something that you have to do, but you should be aware that it's happening. What happens is that the A to D converter reads this voltage and converts it to a decimal number between 0 and 1023. So just to remind you, this is a total number of 1024 possible values. So there's a certain resolution, better than the 16 that we had as an example on the last slide, but now there's a resolution that allows you to have 1024 possible values between 0 and 5 volts that can be read in by the hapkit board. The problem with all boards is that you don't get any perfect measure between 0 and 5 volts. If you had 0.1111111 volts, and there's only 1024 possible values, you're not going to get exactly that voltage measured by your program. So it's good for you to know what this resolution is so that you can check how accurate your system is. So I'm not going to actually go through that calculation now, but there will be a quiz question asking you about what is the resolution of your hapkit board if you can do an A to D conversion with 1024 possible values. So the final step is what you actually program into your hapkit board. And what you will do is use this analog read function in your code. And you specify a pin number and that pin number has to be one that can take in analog signals. And that will read out a decimal number based on the voltage at the specified pin. And the decimal number that it's going to read is going to be a number between 0 and 1023. And what you have to do is either convert that to a voltage or do some other calibration step to figure out what that means in terms of the actual sensor value that was read. And one of our exercises this week will be to actually do that calibration for your hapkit board and the sensors that you have, namely the MR sensor and the FSR sensor.